All right, here we go. Part 2 of the lesson on the fundamental theorem of calculus. Part 1 was walking you through the proof of the fundamental theorem, which again is not something that's ever going to be assessed. What is going to be assessed is your ability to commit this expression of the fundamental theorem of calculus to memory and to understand how to perform it. What we have here is the definite integral from a to b of some function f of x, which remember, when we worked with Riemann sums, we defined as the area under the curve of f of x from a to b. And what we learned when we saw the fundamental theorem of calculus was that that can be calculated by taking the antiderivative of f and evaluating it at b. So plugging in b after you've done that, minus the antiderivative of f at a. And the shorthand we do to write that is that capital F. It means the antiderivative of that function f. And so let's see what this would look like when you are, and this is again something that you'll see a lot on AP style questions, if you are given a definite integral to find, you are being asked to do one of two things. If you are given a graph of that same function, so let's say this is that function f of x, right? This is the line negative 2x plus 3. One way to calculate this definite integral would be to start at 2 and finish at 5 and calculate the area under the curve. So between the curve and the x-axis, in this case it's a trapezoid, it's under the x-axis. So this area is going to be negative whatever it is. And in this case, the way I like to think about the area of this trapezoidal shape, right, it's like we're going to take this base, which is a distance of 3, and we're going to basically be averaging two rectangles. One that has a height, we'll call this height 1 is equal to 7, and another height 2 is equal to 1. And so it's basically the average of 3 times rectangles with heights of 1 and 7. So 3 times, that's 8, over 2, that's 4. This is going to be 12. So I already know the answer to this question is negative 12 because I have access to the graph. But if I didn't have access to the graph, if I didn't have this, I could still find this using the fundamental theorem of calculus. And here is the typical notation that you're going to see. You're going to take the antiderivative and put it inside these brackets. And so the antiderivative of negative 2x plus 3 is going to be negative x squared, right? Because the derivative of x squared is 2x plus 3x. So if you took that derivative, you'd have this integrand, right? And the notation you see, we're going to take that 2 and that 5 and we're going to put them on the right-hand side here. And what this is shorthand for, that f of b minus f of a from the fundamental theorem of calculus. And so what we're going to do is we've already taken the antiderivative. Now we just need to plug in b and plug in a and then subtract them. So we'll break this up into 2 more brackets. If you plug in 5, well, negative 5 squared is 25. I'll write this one out, but the rest of these I'll do really shorthand. Negative 5 squared plus 3 times 5. And then the other one, we're going to have negative 2 squared plus 3 times 2. And so you work this out, and this becomes negative 25 plus 15. That's negative 10 minus, this becomes negative 2. You get here, minus, this is just a regular 2, negative 4 plus 6. And so you get here negative 12. You get the same negative 12. And so these next couple examples, again, just kind of going through really quickly to just show you that finding this through the fundamental theorem is the same thing as finding it area under the curve, but you might be given one or the other. Let's see. Let's just do, I want to show a couple more of these just so you can really get this idea of whether or not you are above or below the curve and how that impacts things. So let's just see, this one goes from negative 2 to 1. And so that would be this triangle here, or this this trapezoid again, right? We already know it's the same trapezoid, right? Base of 3, height of 7, height of 1. We already know this area is equal to 12. And so if I work this out using the fundamental theorem, same thing, negative x squared plus 3x from negative 2 to 1. That's going to be negative 1 squared plus 3 times 1 minus negative, I do that with brackets, negative 2 squared plus 3 times negative 2. And so let's just make sure that this all works out. This becomes 2 minus, and so what we're going to have here is negative 4 minus 6. Yep, this is going to be a negative 10. So what we wind up with here is 12. So once again, you could have done that either area under the curve or definite integral. Notice that the fundamental theorem of calculus includes all of that. So you don't have to worry about above the curve or below the curve if you're using the fundamental theorem of calculus. That includes, right, and so here's one last example like this, if you have portions of the curve that are above and below. So if we find the area under the curve from negative 1, we'll do that in green, from negative 1 to 4. And so we're going to have a triangle portion that is below the axis, and we're going to have another triangle portion that is above the axis here. And so let's see what this works out to be. These actually look pretty much the same. So what we've got here is we've got a height of 5 and a width of 2.5, right? So we're going to have 5 times 2.5. We're going to have 12.5 up top. And let's just check. It looks the same here. Yep, this is going to be 2.5 by, once again, 5. So we're going to have 12.5 minus 12.5. This definite integral would actually work out to be 0. So let's just make sure this happens. One more time here. The notation, it's a bracket from negative 1 to 4, and you stick the antiderivative in there. And so what we're going to have is negative 4 squared plus 3 times 4. All of that minus negative 1 squared plus 3 times negative 1. And so this is going to be negative 4 minus, and yeah, that's going to work out to be minus negative 4. And so this does work out to be 0. Okay? Now, a lot of times the problems are going to be structured whether through a table or in some manner such that you can't actually verify with the area under the curve. And that's why I say whenever you get one of these problems, right, you just need to have this burned into your brain. Can I find this using the area under the curve? If not, it's going to be the fundamental theorem of calculus. It's one or the other. It's always one of those two things. Now, in this case, it's going to be the fundamental theorem of calculus because I can't see f prime. I've got a couple of points, but I can't actually calculate that area. And so what I need to realize is via the fundamental theorem of calculus, the definite integral from negative 1 to 3 of f prime of x, remember, the antiderivative of f prime is just f. So this is just f of 1 minus f of negative 3, which are values that we could look up in the table. F of 1 is going to be negative 2 minus f of negative 3 is going to be 4. So we have negative 2 minus 4 to get negative 6. All right, so you just got to remember a couple things. You got to remember that it's f of b, right? It's from left to right, top to bottom. That's just another thing to remember. From left to right, bottom to top. Sorry, left to right, bottom to top. So you're going to have f of b, which is f of 1, minus f of negative 3 there on that. The answer there would be negative 6. Just looks like, yeah, one last example here. You have to be super careful what you are being asked to take the definite integral of. So you have to be super careful what is my integrand and what have I been given? And so this is one of my favorite examples, because if you are given a graph of f of x, right? You are given a graph of f of x, you have to be very careful, but you can find the definite integral of f of x, f prime, and f double prime, and I'll show you how. If we're asked to find the definite integral of f of x, remember I said it's either going to be the area under the curve or the fundamental theorem of calculus. And so first I'll show you what it's not. It's not the fundamental theorem of calculus. The reason it's not is because we don't have this function. I cannot tell you what the antiderivative of f of x is. But when you have the same integrand as function, people overthink these problems. They start to try and do fundamental theorem of calculus. Don't forget, this literally just means the area under the curve if it's the same function. So for this first one here, for f of x, if we're going from -4 to 2, well, I'd have to find this area here, so like this trapezoid, this triangle, and then this triangle here. Okay, I kind of gave myself like a pain in the butt one to do here. But if we break this up into 3 parts, okay, I've got this trapezoid. It's got a, let's see, it's got a base of 4. And again, if you wanted, you could break it up into like a triangle and a rectangle, or a rectangle and a triangle. Yeah, let's do that. So we've got one rectangle. The rectangle is 4 by 2, so that's going to be 8. And then we have a triangle there down below that's going to be a 1 by a, oh, that's a 3. Yeah, because it goes from -4 to -1. So that's going to be 6. Maybe I'll do those in black so it shows up a little better. This is going to be a 6. And then the triangle below is a 1 by 3, so 1/2 base times height. This is going to be 1.5. So we're going to have to remember that it's negative, right? We're going to have to remember that that's a negative area. Versus the green triangle, base of 2, height of 2, 1/2 base times height. This is going to have an area of 2. So altogether, what we're going to have here, if we have the positive areas, so I'm going to remember this is not the fundamental theorem of calculus. We are not using that. We're just using the green versus the red here. We're going to have 2 minus 7.5. The area under that curve would be equal to -5.5. Now, if I asked for the definite integral instead of f prime, these are actually going to be easier in this case, because if I ask you for the definite integral of f prime, the thought process needs to be the following. Do I have a graph of f prime? No, I have a graph of f of x. I can't find the area under the curve. Therefore, it must be the fundamental theorem of calculus. They must be asking me to find f of 0 minus f of -4. And what do you know? I know those things. F of 0 is this point right here. F of 0 is 0. I know that. F of -4 is -3. I know that. 0 minus -3. This is equal to 3. And so if you just always think area under the curve or fundamental theorem, which one can I apply? One of those two will work out. Okay, last one here, and then this is the end of this video here. If I was asked to find the definite integral of f double prime, again, first thing you want to think, can I find the area under the second derivative? No, I don't have a graph of the second derivative. It's not possible. If that happens, it is going to guaranteed 100% be a fundamental theorem problem. Now, if you take the antiderivative of f double prime, you have f prime. So this is f prime of 2 minus f prime of 0. And again, this is the FTC. This is the FTC, the fundamental theorem of calculus. The first one is the area under the curve because it's not possible. Now you may be saying, wait, but I don't have, how do I find f prime of 2? Most important sentence in calculus, the derivative is the slope of the tangent line. So you do have f prime of 2. f prime of 2 is the slope of this line. So it looks like we go from 2, 0 to 3, negative 2. So if I just look, change in y over change in x, well, we go down 2 over 1. That slope is going to be negative 2. So this first slope is negative 2 minus f prime of 0 looks like up 2 over 1, right? Up 2 over 1. I'll make that kind of a dashed line there. Up 2 over 1, or I'll just kind of draw that line in purple so you can tell. Up 2 over 1. That slope is going to be change in y over change in x equal to 2 over 1. And so we're going to have negative 2 minus 2. This is going to be equal to negative 4. And so as you're working on the materials for this week, this is probably the best page to look at. But really, you do have to commit to memory. You do have to memorize the fundamental theorem of calculus. It's super important that you memorize that if you have a definite integral from a to b, it's the antiderivative at b minus the antiderivative at a. But be very careful, depending on what your integrand is, it might be an FTC problem. It might just be straight area under the curve.